In today's tutorial we will have a look at the synthesis of luminol. Here is the structure of luminol, a very important compound in forensics since it enables to detect traces of blood by a luminescence. So it's important to have a cheap and reliable synthesis for that, and the cheapest starting material should be this phthalic anhydride. Well, if you want to introduce an amino group, this is usually done by electrophilic aromatic substitution, first introducing a nitro group, later on reducing it to an amino group. So, and introducing that cyclic hydrazide is not a problem. You can do that with hydrogen at elevated temperatures. So, now to the problem. For an electrophilic substitution, it's good to have an activated aromatic system and at least not a completely disactivated system. So a carbonyl group deactivates ortho and para position. So this carbonyl group deactivates this position and that one. The other one then this and that. And that means all positions are deactivated. Surprisingly, just with HNO3, it works just fine and selectively to produce this nitro compound in high yield. So how can we explain that? In the first step, the HNO3 will react with the phthalic anhydride, protonating, open up the 5-membered ring and producing this one. What is that? This is a mixed anhydride of a benzoic acid derivative and the HNO3. So, and how can we explain that? Well, you certainly remember the sentence, the stronger acid displaces the weaker acid from its salt. The same is of course true for anhydrides. So the stronger acid displaces the weaker acid from its anhydrides. So here we have the mixed anhydride. And now the nitration of the ortho position should proceed intramolecularly. Therefore, that electrophilic nitrogen has to come by rotation of that group in close proximity to this position. And now, in this conformation, the carbonyl group is orthogonal to the aromatic system, therefore not conjugated, and therefore we don't have the deactivation here in the ortho position, just in this situation. So, a bond is forming between this carbon and that nitrogen. Never draw a nitrogen with 5 bonds. 4 bonds is the maximum. So we have this reactive intermediate, then it's a sigma complex with this stabilized conjugated cation here, and now this can fragmentate the oxygen, this one or that one, the oxide, this one or that one, pushes in electron density. This nitrogen-oxygen bond will break, and now we have this situation. So, typical for a sigma complex within the electrophilic aromatic substitution. Here, this carboxylate is basic, will deprotonate here at this position, And that's it. We are already at this first intermediary product on the way to luminol. Thanks for listening.